Hello, today in this class we shall discuss about the concept that is absolute temperature and what is the meaning of perfect gas equation, and we are going to derive one of the important derivation. We are going to show that alpha V is equal to 1 by T. So by using Boyle's law, Charles law, and we are going to see what is the meaning of specific heat capacity of a substance. So we know, so first we shall see the meaning of absolute temperature. So absolute temperature is, that is one of the temperature on the Kelvin scale that we are going to call absolute temperature, and the meaning of absolute zero is, that is the lowest temperature on Kelvin scale, that is almost equal to minus of 273 degrees Celsius, that we are going to call absolute zero. So here, for what we are going to call ideal gas equation or perfect gas equation means the gas which obeys all gaseous laws. So that we are going to call ideal gas or perfect gas equation. And by using perfect gas equation, so we are going to show that is PV is equal to N now. So we know from Boyle's law, so V is directly proportional to pressure at constant temperature, and according to Charles law, so V is directly proportional to temperature at constant pressure. So Boyle's law, that is considered equation 1, and from Charles law V is directly proportional to consider that one as equation 2. So combining equation 1 and 2, we have the relation V is, so VV is same, so 1 by P. So here T is there, therefore it becomes T divided by T here. So here from this, so PV is equal to nRT from ideal gas equation, where N is for N number of moles, N means. So here if you put N is equal to 1 for 1 mole, the equation we are having PV is equal to RT, because N value is substituted 1 here. So if the values, pressure is P1, volume is V1 and T1 are the initial values, P2, V2 and T2 are the final values, then that condition we are writing that one as P1 divided by P1 into V1 divided by T1 is equal to P2 V2 divided by T2, that's equal to constant. So if this P1 V1 and T1 are the initial values, P2 V2 are the final values means, so this is the formula we are writing like this. So for ideal gas equation. And next we shall see how we are going to derive alpha V is equal to 1 by T for the ideal gas equation. So here this may ask for 3 marks, it is very important. So we have perfect gas equation is given by PV is equal to RT, let us consider that one as equation 1. So on differentiating this equation, so P is kept as it is, so this is second factor is differentiated, dV is equal to R is kept as it is, this differentiated dt. So consider this one as equation 2. So next equation 2 divided by equation 1. Equation 2 divided by equation 1 it becomes, so P into dV divided by PV. So same thing we are writing. So is equal to R into dt divided by RT. So we are dividing equation 2 divided by equation 1. This is equation 2 and this is equation 1. So then it becomes like this. And here this PP gets cancelled, RR gets cancelled, remaining dV by V into 1 by dt. If you bring this one, it becomes, so this is on right side, if you bring here, it becomes divided by, so dV by V into 1 by dt is equal to 1 by T. So from this dV by V into 1 by dt, that is kept as alpha. If this whole thing is kept as alpha, so here this is alpha V, substitute this one as alpha V. Means in order to reduce the equation, we substitute that one as alpha V is equal to 1 by T. So this is the condition, definitely they may ask for 3 marks. This is one of the important derivation they may ask. And next we shall see what is the meaning of specific heat of any substance. So why we are using specific heat? So specific heat, that is used to measure the heat. So when we heat any object, the temperature of the object is going to increase. When we cool the object, the temperature of the object is going to decrease. So here for different bodies, of same mass, they are having different quantities of heat. So they require different amount of heat. So quantity of heat absorbed, that is represented by dq, is directly proportional to mass of the body. So mass of the body is represented as m, and that is directly proportional to rise of temperature. So rise of temperature is represented as dt here. Therefore, so different bodies of same mass, they require different amount of heat, but the quantity of heat absorbed dq is directly proportional to mass of the body, and it is directly proportional to rising temperature. And therefore that is given by the formula dq is equal to m into dt, or you can represent, so dq is equal to c into m into dt, where c is constant. So the constant value that depend upon nature of the substance, and the specific heat capacity of a substance, given substance ಅಂತ represent ಮಾಡಾಕ c ಅನ್ನೋ ಲೆಟರ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. c ಅಂದ್ರೆ ಏನು, specific heat capacity of a substance ಅಂತ represent ಮಾಡಾಕ c ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಹಾಗಾದ್ರೆ specific heat capacity of given object ಅನ್ನು ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? So quantity of heat required to rise the temperature of unit mass of substance through 1 Kelvin. Avaga specific heat capacity of a substance is given by the formula C is equal to dq divided by m into dt, and always specific heat capacity is measured with the SI unit joules per kg per Kelvin, and dimensional formula used to measure specific heat capacity of a substance is m0 L to T minus 2 and per Kelvin it is. So this is all about specific heat capacity of a substance.